the distance between this point is equal to 1.8. Okay. So you can say the change in y over the change in z. Okay. So the change in y, for this case, I'm going to pick 1.8 divided by 208.333 plus by 291.667, and this is equal to y divided by 208.333. So y will be equal to 208.333 times 1.8 divided by 208.333 plus by 291.667 close bracket is equal to 0.75. And this is from point D. Okay, so you can use this method, or another technique that we will use, okay, which I will show you, and I will copy all this again. Okay, so this is one way of doing it. Another way that you can do it, and the answer will be the same, right? Is using stress X is equal to P over A minus by or plus by my over Iyy multiplied by z minus by mz over Izz multiplied by y. Okay, so we are aware that along the neutral axis, right, stress X is equal to 0. Okay, so when we apply, so we know that the above equation becomes 0 is equal to P over A plus by my over Iyy multiplied by z minus by mz over Izz multiplied by y. And if we see how the moments are applied, okay, if we look at the moments that we have, so the moment are acting, so this is your my, sorry, mz, and this is your my. And if you use the right hand rule, both are positive. Okay, right? If you use your right hand rule, so your thumb point on the z-axis and you grab, they are all positive moments. Okay, so we are going to find, yeah, so first thing we're going to do, we're going to find where the neutral axis intersect line AB. Okay, so we know on line AB, y is equal to positive 0.9 inches. Right? If you look at the location of line AB, right? 0, 0 is at the center, right? So when it's along line AB, this will be equal to what? Positive what? 0.9 inches. Okay. So now we have to find, Z. Okay. So we know the formula is 0 is equal to the P over A. We know the value, right? P over A is equal to 125. Okay. P over A is equal to 125. And plus, now moment about y. Okay, so moment about y is 800 multiplied by z is what we don't know. We want to find. And then divide by IYY. So IYY, we found it to be equal to 9.6. Okay. And then minus moment about Z is also positive. So it's equal to 540. And we know that it's positive 0.9 divided by IZZ. So IZZ is 1.944. Okay. So when you calculate this out, okay, so 800 divided by 9.6. So it's equal to 250 over 3Z is equal to 540 times 0.9 divided by 1.944 minus 125 is equal to 125. So Z is equal to 125 times by 250 divided by 3 is what am I doing? 250 125 times 3 divided by 250 is equal to 1.5 inches from the centroid. Okay. So Z is 1.5. Okay. Now, when we calculated with that other formula, our Z, sorry, this is Z, not X. Our Z is equal to 0.5 inch. Now later on, we will see whether do we get the same point. Okay. So let's carry on first. Okay. The next thing that we're going to do, we are going to find. So we find where it intersect is positive 1.5 inch. Then we're going to find or determine the neutral axis intersection or intersect line. Now we want to find along line BD. And on line BD, right, we realize that Z is equal to minus 2 inches, right? Because if the center is 0, 0 BD, this distance is what? Minus 2, right? And then now we are going to find Y. Okay. So again, you have 0. This is equal to 125 plus by, now we know Z, so 800 multiplied by minus 2 divided by 9.6 minus by 540 multiplied by Y is what we want to find, divide by 1.944. Okay, so this will be equal to, so I'm going to bring the 540 across. So 540 divided 1.944 is equal to 2500 over 9. And this is Y, and it's going to be positive. Let me do it. 540 divided 1.9. Yep. So the next one is 125 minus 800 times by 800 times by minus 2 divided by 9.6. Okay. So plus by 125. Now it's minus 125 over 3. So Y is equal to 125 over 3 times by 9 divided by 2500, 0.15. Okay. From this, so minus 0.15. Oh, my eraser not working now. Silly eraser. So Y is equal to minus, let me do get 125 plus by 800 times by minus 2 divided by 9.6. Yep. So 125 over 3 times 9 divided by 2500 is equal to minus 0.15 inch from the centroid. Okay, so now we are going to sketch where the intersecting points of the centroid are. Okay. So this is 8. Okay. And then I'm going to sketch our axis. Okay. So one the centroid, so we know that this is our positive z direction. This is our positive y direction. Okay. So on z is positive 1.5. Okay. So this is our one of our point. All right. So the distance from here to here is 1.5 inches. Right. So this is where we have our point A. Right. Then we have our point B and point D. But based on the formula that we are currently using, right, the y is minus 0.15, right, minus 0.15. So 0.15, so this from here to here, this distance over here, right, from here to here, this is our 0.15. So it intersects somewhere around here. Okay. So we draw a line here, intersect here. So this is our position of our orientation of our neutral axis. Okay. So now going back to our calculation, we use simple math. Okay. Right. So from point D, the y is 0.75. So the distance from point D, right? I'll use a different color now. We calculated that this distance from here to here is 0.75. And the entire distance from here to here is equal to 0.9. Okay, so 0.15 plus by 0.75 is equal to 0.9. So it's calculating the same point. One is relative to the centroid, the other one is relative to a point that we define. And then if we were to use our method again, the simple method is 0.5 down here, right? And we calculate that from here to here, right, is also 0.5 inches, right? And it's the same point, okay, because this is equal to what? 2 inches. Okay. So both method, okay, you use both method, the answer will be the same. Okay, both are exactly at the same point. Okay, the only thing that is not necessarily difficult for this of when you're using the formula is you have to be aware about on whether you are finding y or z, and you have to know whether your my and mz are they positive or negative. Okay, if you are unsure, okay, I've just shown you a method that you can use that applying your high school math would do. Okay, could we use the line CD while y is equal to minus 0.9? Okay, so point CD, wait, let me see where is point C. So I suppose you will say point C over here, right? Now, whether you use that or not, you have to find out, are you going to get tensile or compression, Hampo? Hampo, that is a very good question. Okay, so let's determine the stress at point C. Okay, let's determine the stress. I'll go 5 minutes on, then we do a go for a break. So the stress at point C, right? And we know that this is 250 over 3, right? Or not 250 over 3. We go back to this value over here. We know it's 125, right? And then the other two value is 500 over 3, 250. Okay, so we know that this is 500 over 3. This is, the next one is what? 250. Okay, I don't know whether is it positive or negative yet. So we know that this is your my, and this is your mz. So this is your, the 250, this is for your my, this is for your mz, right? So the 250 over here will be having a tensile, right? And the mz, so the tail end is tensile. This is also tensile. So this is plus also. So this come out to be 125 plus by 500 divided by 3 plus by 250 is equal to 541. Okay. So if you look at 541.667 over here positive, we know that the neutral axis will not intersect this line or this line, right? Because point A is positive, point C is positive, and point D is also positive. Hangpo, does that make sense to you? So from here, we know, right, that the y-axis or the neutral axis cannot intersect AC or NCD. Does that make sense? I mean, mathematically, unfortunately, mathematically, you will get an answer. Okay, but the answer don't mean anything at all. Okay, okay, let's go for a 5 minutes break. Okay, we come back at 8:10. Okay, that is a good question.